This video discusses simplifying expressions containing rational exponents. A rational exponent is simply an exponent that is a fraction. We can simplify expressions containing rational exponents using our regular exponent rules, like we've learned for integer exponents. So with product rule, we add our exponents. When we're dividing, we subtract our exponents. Power to a power, we multiply our exponents. If you have a product or a quotient, an outer exponent is applied to everything inside the parentheses. To eliminate a negative exponent, you take that factor to the opposite side of the fraction, and anything raised to the 0 power is always equal to 1. The steps I like to follow for simplifying expressions with rational or any exponent are as follows. I always start by applying the outer exponent to everything on the inside. Then I apply power rule and multiply my exponents together. I eliminate negative exponents by taking factors to the other side of the fraction. I'll apply product rule to combine variables on the same side of the fraction, and I'll add the exponents. Then I apply quotient rule to combine variables on opposite sides of the fraction. Here we'll be subtracting the exponents. And then lastly, I evaluate and simplify the numbers. Let's simplify each of these expressions, and we want to make sure to write our answer with positive exponents only. 8x to the negative 1/5 y to the 1/3 times negative 3x to the negative 1/4 y to the 1/6. All we're going to do here is kind of like pair up. Notice that we have coefficients, x's, and y's. We're going to multiply like types together. Multiplying my coefficients, 8 times negative 3 is negative 24. Now here I have x to the negative 1/5 times x to the negative 1/4. When multiplying, we need to add our exponents together, so we need to have negative 1/5 plus negative 1/4. You can either use your calculator for this or get a common denominator and add them together. Either way, we're going to get negative 9 over 20. I need to do the same thing with the y's. So I have y to the 1/3 times y to the 1/6. I'm going to have to add those exponents together, 1/3 plus 1/6. This is going to give me y to the 1/2. I want to eliminate any negative exponent. We do that by taking it to the other side of the fraction. So if you don't have a fraction, like we don't in this case, we'll just make one. And only the factors with a negative exponent get moved. The 24 does not get moved. That is not a negative exponent. That's a negative 24. Negative 24 and y to the 1/2 stay on the top. And then x to the 9/20 moves to the bottom. And there's our answer. In our next example, notice that we have an outer exponent. An outer exponent gets applied to everything in the inside when the operation inside our parenthesis is multiplication or division. So we're going to have to apply it to the 9, the x, and the y. This will be 9 to the negative 1/2, x to the negative 4th to the negative 1/2, y to the 8th raised to the negative 1/2. I always like to leave the numbers to the very end because a lot of times when people try to figure out what 9 to the negative 1/2 is early, they end up making a mistake. So I recommend you keeping that for last. But I will deal with the x to the negative 4 raised to the negative 1/2 and y to the 8th raised to the negative 1/2. In both those situations, we have a power raised up to a power, so we need to multiply those exponents together. Negative 4 times negative 1/2 gives us positive 2. 8 times negative 1/2 gives us negative 4. The next thing we want to do is eliminate any negative exponents by taking it to the other side of the fraction. So I'm going to make a fraction. This is going to be moved down, and this one's going to be moved down. X squared stays on top by itself. Now we have 9 to the positive 1/2 and y to the positive 1/4. At this point, our negative exponents have been eliminated. All of our variables have been combined. It's time to evaluate that 9 to the 1/2 power. Remember that a number raised to a rational exponent can be rewritten as a radical. The 9 is our radicand, the denominator is our index, and the numerator is the power that we're raising all that to. So the square root of 9 is 3, raised to the first is 3. We get a final answer of x squared over 3y to the 4th. In our next two examples, not only do we have fractions in our exponents, but we also have variables in our exponent as well. One of the things I love the most about math is that the rules don't change. Even when the numbers change, even when things look weird, the overarching algebraic principle does not change. B to the m over 3 divided by b to the m. I have division here with the same base. That's just basic quotient rule. This is the same as if we had b to the 4th over b to the 2nd. All we need to do is subtract our exponents. So let's do that. We're going to have m to the 3rd minus m. It's going to be a little harder to have your calculator help you here. I would encourage you to just do the subtraction by hand. We'll get ourselves a common denominator of 3. So this second fraction becomes 3m over 3, because I had to multiply top and bottom by 3. 1m minus 3m gives us negative 2m over 3, so that's going to be our exponent. We get b to the negative 2m over 3. And as always, we want to eliminate any negative exponent, and we'll do that by just taking this to the opposite side of our fraction. We end up with a final answer of 1 over b to the 2m over 3 power. Next, we have x to the n over 2, y to the n over 3 raised to the 6th power times x. So I want to start by applying my outer exponent to everything inside my parentheses. This is going to be x to the n over 2 raised to the 6th, y to the n over 3 raised to the 6th, and then we just have that x hanging out on the side, multiplying. We have a power raised to a power 2 times there, so we want to multiply those exponents together. And maybe you want to do some side work here. N over 2 times 6. I can do some canceling here. We end up with 3n. So this is x to the 3n. Same kind of thing with the y. This is going to be n to the 3rd times 6. We can do a little canceling here. This is going to leave us with 2n. And then we still have that times x over on the side. Now, I got to do something with these x's here. We need to put them together. What would you do if it was just x to the 3rd times x to the 1st? We add our exponents. That overarching mathematical principle does not change here just because we have a variable in the exponent. We need to add those exponents together. 3n plus 1 is equal to 3n plus 1. So we get x to the 3n plus 1 times y to the 2n.